So we're going to start our discussion now of SUMA. This is the surface mapping part of the AFNI package. So this is usually a lot of fun for everyone, and we get really, really pretty pictures. So I think everyone will like that. Okay, so we know about AFNI. We're able to look at functional activation inside AFNI. We can look at graphs there. We can even render inside AFNI, but that still looks inside the volume with a volume renderer. We have cuts through the volume in our rendering plugin. And now this is the Summa software where we can map things onto the surface. So the same data mapped onto the surface. We can look at that in a different way. We can also analyze our data on the surface. Okay, so Summa is a complement to AFNI. It does, so AFNI does slice and volume rendering. Summa does surfaces. Now Summa also does slice and volume rendering. So you can look at a lot more data with Summa by itself and in combination with AFNI. We'll show some of those things today and some of those things tomorrow. We support surfaces that we can get from other software packages. FreeSurfer, namely, I think SureFit and Carrot aren't supported anymore, and they've gone over to their Workbench software. That's okay because they also write Gifty. So instead of Nifty for volumes, we have Gifty for surfaces. So Gifty is available as a standard across software packages, and so we can look at Gifty data sets too. Brain Voyager also produces these kinds of data sets. We can read and write lots of different surface formats, so getting data in isn't usually too big a deal.
So then everything that is produced with the connector workbench is also read by Summa.
The Connectome Workbench, a lot of the things are in SIFTY. SIFTY, yes, another one, because we need more file formats, yes. So SIFTY is a combination format. I forget what SIFTY actually stands for, but it's what?
The S surface.
You know, it's with a C. CIFTI. Rick will know because he was part of the committee, but he left the room just in time. And we have some tools for looking at the header of SIFTY data sets, but but manipulating them is a little bit more difficult. It's a wrapper for Nifty and Gifty, and functional Gifties, which we'll talk about, which are like our NIMH data sets. So ways to values that we'll assign to the nodes of a surface we put into a data set that we call NIMH.dset, which can also be in a SIFTY or Gifty format, the functional Gifty format. So now that Rick is back, we can ask him, he said, don't run away yet. What does SIFTY stand for? What's the acronym? You don't remember?
Well, it's all Gifty based. Mechanics.
Yeah, but I just can't remember the connectivity. I don't know, we could Google it, but that's too hard. Okay. All right, so let me keep going. So AFNI, the AFNI package, Summa, we generally don't produce surfaces ourselves. So if you're going to look at surfaces, you will generally get them from somewhere else because we don't make them. Mostly. We started a little bit. So we do have a way to make some surfaces, and I will show that tomorrow. But most of the surfaces that you will get will probably be from FreeSurfer or from the Workbench, the Connectome Workbench or something like that. Oh, I could say FreeSurfer, yes. Yes. So yeah, so a lot of our AFNI users use FreeSurfer. We mostly recommend it, and it works well for generating these surfaces. There are limitations. Maybe we'll look a little bit at those too. This slide is a little bit old. Before you run FreeSurfer, you don't actually have to run the 3D Uniformize, which has now been replaced by 3D Unifies, which is a good program to know about, but FreeSurfer does its own N3, N4 normalization anyways. But It probably doesn't hurt to do it before FreeSurfer too. But I think in general, we don't actually do that. So FreeSurfer's gone through a lot of generations. SureFit is not available, was wrapped into Carrot. Carrot is now replaced by the Workbench. So, and some people actually use Brain Voyager too, which is a commercial package for volume and surface analysis. Okay, so let's assume you've got your surfaces out of FreeSurfer. Then you can bring them into Summa, and in Summa it will create what's called a standard mesh version of those surfaces, something that can be compared across subjects onto a common mesh design, and so node for node correspondence across subjects. And then we can align our data, we align our surfaces with our own experimental data. FreeSurfer, while it's a very good program, is very slow to generate a surface. So it can take a day or 2 days for creating a surface for any particular subject. And you may not want to do this for every session of every subject. So if you have multiple sessions, you can use the surface that was generated from one particular session and apply it to another by doing an alignment with this @Summa aligned to experiment, and we'll just transform that surface over into the experimental space. We'll show you how to take the volumetric data and map it onto the surface. So the MRI data is volumetric. We're going to use part of that data in the surface domain. So we're going to look just at the surfaces. That has some advantages and some disadvantages. And we can also look at the time series on the surface. And it's important to know, and interesting too, that we can do our analysis of surface data in almost exactly the same way that we analyze volumetric data. And the reason is that most of our 3D programs aren't really 3D, in that they will just take any list of numbers and treat them as time series. As long as they're not spatially oriented, they will work on surface data sets. So all of our things like 3D calc and temporal smoothing or time, well, not slice timing, but slice timing is a spatial thing, so that won't work. We have other programs also for clustering on the surface too. The group analysis doesn't care where your data is. It will, as long as there's a correspondence across subjects, it works. So even if you don't go through any of that process, you can still look at your data on the surface. So this is the simpler thing that you can do readily. And we provide surfaces for you for the N27 data set. These are either in Telerik or MNI space. It doesn't really matter here. You can, if your data is in one of those spaces, you can just map it on, map the surface, map the data from your volume onto the surface. This is super easy to do. We'll show you how to do that. Now, it's a different subject, so different subjects, it won't map perfectly well. It's not as good as mapping to the surface of that of your subject. So you would probably want to do this for your own subject, but if you just need something quick to just get an idea of where this activation is in some 3D in a nice visualization, then you can do that here. So we provide a script called @Summa make spec, and for FreeSurfer it's make spec fs. And so FreeSurfer generates all these kinds of surfaces. Carrot also had done the same thing. Workbench also provides these kinds of things. For FreeSurfer and for Carrot, we have scripts that will make a spec file. So a spec file is a specification file, a text file of how the surfaces are related to each other and the names of the surfaces.
If I have one volumetric data, let's say the normal brain. If I want to convert to expand the brain, I need to keep all the surface separated, right? There's no conversion between fiducial and expanded.
Yeah, so we don't make the expanded version. FreeSurfer does that, and Carrot and Workbench make that. FreeSurfer has some tools for kind of going after the fact too. There are also tools for making flat maps. We don't do that. We do provide the ones that we've done for the N27 data set. We also have the MNI 2009 C template that we've converted to a surface. So even though it's a group data set, Paul Taylor recently made a surface out of that. I think Rick will be presenting that. So, and that worked pretty well too. Okay, so we've got Summa make spec FS. Okay, so let's start Summa. I'm not going to change to this directory. So I'm going to start in a different directory. We're going to start in SUMA Demo AFNI instead of Surf Data Summa. Okay, so you should have a SUMA Demo AFNI someplace. Just start a terminal someplace. Let's see if I have. And let me minimize this over to the side here. We're going to need a lot of space for all the things we're going to look at. Okay, so on my system, this is where SUMA Demo AFNI is. Can you see that? I don't know if that's big enough. So CD to that directory. And in that directory, we can start AFNI. And we're going to start it with AFNI-NIMH ampersand. Okay, so the -NIMH means it put it in a mode that it can talk to the world. It's the same neuroimaging markup language, but this time it's used over TCP/IP, and so Summa will be able to talk to AFNI. We'll show you that. The ampersand means put it in the background, and actually that's not needed anymore because it automatically starts in the background. And then there's the Summa command, but I'm going to run the run Summa script instead with the tcsh run Summa in that directory. And we can look to see what that is so that there's no black magic underneath. Okay, so it's really just one line that's really doing everything here. Is Summa-spec. You give it the name of the spec file, the specification of your surfaces, and then an alignment volume, the volume that's aligned to your experiment. So FreeSurfer provides a data set that's aligned to the surface, and then you align that that volume to your experiment, and that's this one, and it contains a transformation within its header that will move the surface if we need it. In a lot of cases, it will be the identity. There isn't any transformation really at all, and we'll just keep it in its own space. All right, so I'm going to run tcsh. You should run the same. Let's see if I can type tcsh, run Summa. And did I type AFNI-NIMH? Okay, so AFNI-NIMH. And here's Summa over here. So you've seen your first surface. I'm going to close some of these windows to give me some space here. So let's make this bigger. Okay, so you have a surface open, and it defaults to the smooth white matter surface. Okay, and Summa Demo AFNI directory. Now, if you're running a Windows laptop, sometimes the OpenGL that this uses is not as pretty as others, but it will generally work. It might be a little bit flickery, but it will work. I think Windows needs to improve the OpenGL performance on their Linux subsystem, but I found that mostly it will get to where we need to get to. Okay, so now once this is open, you probably want to do something with it. And well, the instructions say have it talk to AFNI, so we can do that. First, what do we want? Yeah, I guess we can keep that there. Okay, so let's do T inside Summa. Press the letter T over the Summa window. And you'll see a lot of things are going on. And in AFNI, let me put this back on because I think it'll be easier to see. You'll see that we've got these contours set up in the AFNI GUI, in the image viewer. So if we zoom in, and I can pan over, see we have different surfaces. These are the contours of the surfaces. Summa has sent the surfaces over to AFNI. And AFNI in return has sent something back to Summa. There it is in the back of the brain. AFNI is sending over its volumetric data to Summa from the overlay.
What's the overlay?
The overlay here is the delay from a retinotopy experiment. It could be anything, really. I mean, it's whatever the data set happens to be, but by default it is selected an overlay here for us. But you can turn on and off the overlay, and it will remove that from Summa.
What's the name of the overlay?
I have it as the demo subj ECC exp avir.del plus a ridge. I guess I can just show you. You don't have that in your SUMA Demo AFNI directory?
Yeah.
You do have it, okay. And it's set to automatically show the delay and the covariance for that delay. All right, so moving the surface around, we need to, let's go down through this. And you'll notice that data sets, if they're done through FreeSurfer, will automatically have the segmentation show up inside Summa. So here it shows us that there's a node clicked someplace. That's the Calcrin sulcus. Okay, so we'll go and click at various places, and you'll see. Okay, so well, anyway, for now we don't need to actually look at the colors on it. We can turn off the overlay for now. Rick will go through the Volta Surf part. I just want to show you other aspects of the surface to start. Although in the end, this is the part you're really interested in. But let's save that as for a surprise later. So I turned off the overlay in AFNI, so the surfaces in Summa are just gray. They're colored actually by the convexity. So there's a two-scale, there's a two-level grayscale on the surfaces. Plus there's lighting in the OpenGL system that gives it a shading. All right. Okay, so you can move the surfaces around if you haven't already by dragging with your left button, the left mouse button. Okay, I'm sure we have this someplace here. Yes. Okay, so the mouse button 1 will let you drag this around and rotate the volume. And you can rotate it in either direction. And you can use the arrow keys. So the arrow keys are handy if you want to move in small increments and you want to record that. Like AFNI, Summa has its own resource file. It's called .summarc. There's a long list of options there, variables that you can set if you want to customize Summa to work the way you want it. Okay. Now this one we call the walnut brain. Okay, so mouse control button 1. Okay, so we're going to do control and hold button, the same left button down. I think everyone will like this. Ooh. So you can have them applaud. Yeah.
How did you do that? Mouse?
Control and the left mouse button. Yay.
You mentioned that keyboard shortcuts.
Did I skip that? I think, yeah, for some reason that's in another order here. But, oh, yeah. That's what you mean, the keyboard shortcuts. We have the keyboard shortcuts. Where do we have those keyboard shortcuts? In the Handouts directory. Let me put that in the background. Yes, so we have a file here. What's it? Summa keystrokes. So let me open that up because that's a handy file to look at. I'm going to open it with my editor. Okay, so let's see if I can make that bigger. So this is in your Handouts directory. You can see the main keystrokes that are useful for Summa. There's a fair number of them. So we've talked about left click drag and the control left drag. We have a bunch of other ones here. Let's go through some of these things. Okay, so if you are finished with the walnut brain, this is actually a useful thing. Despite being fun to look at, it's also useful. We'll look at it with the DTI data. Let's see. So control left double click will put that back together again. So if you do control right and left and up and down, you can get to kind of cardinal views of it. Control left, right, up, down. And zooming in is done through the scroll wheel. That's the way I like to do it. I think you can also do the Z key. Uppercase Z zooms in like as an AFNI, and lowercase z zooms out. Or use the scroll wheel. If you hold the middle button down, you can move it to the side. Yes, you can zoom in with holding two buttons down, the middle and left also, but I never need to do that. Now another thing you can do is you can click on the surface with the right mouse button. So in Summa, the selection of a node is by right clicking. So let's do that. Right click on a surface, and you'll see that because it's talking to AFNI, AFNI will bring it to that location. So this, we're looking at white matter. Where is it in the brain? Let's move to a different spot. Where we click, it takes us to a different spot. I've clicked on a whole bunch of Summa locations, so it sends each of them in succession to AFNI. And you can see that in Summa, the current node is shown with this little crosshair, this three-dimensional crosshair. Right click. Yeah, so, it depends on the version of the OS too, which one it is. Usually it's the right click, but if it depends on your mouse configuration. Um, yeah. And some of these things you have to either disable Mac shortcuts, or even Linux can override some of these things too. There are a lot of keystrokes. If you've moved this off to the side someplace and you want to get it back, you can bring it home by hitting the home key. So function home. And the instructions say function left arrow on Macs. Although I think it usually worked with the home key for me. But now is another fun feature. The M key, this turns on momentum. And when you turn on momentum, nothing happens, but it will. Okay. So if I take my cursor now and I rotate and I let go, see? It's kind of like, yeah, it's a little bit Odyssey, 2001: A Space Odyssey. Now, you can do it faster, right? It'll go as fast as you can move your. Yes, you can. In fact, this is the danger of momentum, because momentum will write out a very long movie if you're not paying attention. And I did this in a class, and I talked a little too long after I did that, and it uses up all your memory and crashes your system. So that's not good. It just crashed Summa, so that wasn't so terrible. But all right. So yes, you can save a movie. Mostly this is for fun, but saving movies is the one place where it's good. But if you are saving a movie, I would say, just do it with an arrow key. And tomorrow, I think I'll show you how to draw so that it will do it for you, and you will just have the script send an arrow key to Summa. So it's very controlled, and it will do that. But you can hit just an arrow key. Oops, let me put this. You can control the speed of the how big an arrow key moves to. It's a Summa environment variable. Okay, to turn momentum off, press M. Okay. One thing you should know here is how to get help, because everybody needs help once in a while. So here it is. You can do help by either clicking on the help button on the top there, or, well, that's probably a good way to do it. And so help, you can do Control A to this usage, or just click on usage there, and it'll show you a fairly long description of the things that Summa can do. Yes, and that's probably the way that you'll get most of your help. But you can also go to select Web Help, and so we have more in our documentation. We have a fairly long description of Summa. This is where this ought to point to, but we've moved over our web recently, so it's in the wrong spot. Anyways, you can see things like this with images. It's a very nice demonstration of how to use Summa.
Can you change the direction of light, brightness, shine,
You can, and that's in the environment variables. Almost no one ever does this, but it is available. You can change the light from the. If you look for the light, we have some things that are available. Probably just going around again and again through this. Yeah, I think I've crossed through this. Let's go back to Summa. So here you have some things on light. So you can flip the light with an F key. That's one of the things that you can do. So you can go ahead and try any of those, the capital F. So the light is in a different direction, so you get a darker shading that way. Let's see. You just hit enter on here. Takes you to the next occurrence. Highlight. Highlights XYZ coordinates, so you can move the light around. So OpenGL has a light location. In the default mode that Summa runs in, there's one light. So you can move that light around by changing the coordinate here by hitting capital L. This is a kind of pretty advanced feature. You don't have to do this. If you want, and there's a couple more things about Control L changes the specularity and diffusivity of the light. You can also add in another light. So Summa actually has the possibility to add in another light in space, so you can get things better lit.
To make all my changes before, I have to add the .summa RC.
Yes, .summa RC controls those things. So there's a bunch of settings for light. If you need more light, I can turn on a light for you. So it's not just a switch, though. It's actually code. Oh yeah. Appeal service. Oh yeah. So I'm gonna get to that. I think it's next on the list. Oh no, the one other thing to do before this is the recording the pretty pictures. So let's see, you've got some pretty picture that you like, and then you can just hit R to record it into a recorder. And there we get another view. It looks just the same. And I can do another view over here, and then I get another one like that, another one like that. And this opens up this recording viewer, which is just like a viewer inside app. This has its own recording viewer. We didn't talk about it here, but this has a record button. This opens up the same kind of viewer. And you can see this lets you go through your recording. So just before the class, I was recording something for tomorrow's class, something that takes a little bit longer to generate, and you can look at it. This works like an AFNI image viewer, and then you can turn V on. So right now it's just 3 images, so it kind of flips among all those things. But if it's a nice smoother video, you can record that here. If we turn momentum on, and I'm going to do it with just the arrow key and as slowly as I can. So M, and then right arrow. Oh, I'm sorry. Yeah, I didn't turn on the recording for keep recording. So if I want to keep recording, I have to do capital R. So up R over the Summa window. And now I'll do that again. Right arrow. Okay. And then I'll do uppercase R. Again, the momentum is still going, but the recording has stopped. Okay, so over here, I've got my image viewer. I've got a recording of that. And I can save any particular image with the save button here. So I can save that one as this surface view. And then set that. Or I can right click on it and say, I want to save it as an MPEG file, and then save the whole thing as a movie. So I can put that on my web page, I can put it into a presentation. Really nice videos that you'll be making with these things. Okay. Yeah, you can have it record to the disk too. You don't have to do this manually and type it out. You can do Control R and do that, or you can have a drive Summa script, drive Summa to record for you. Okay, so AFNI and Summa talk to each other with this neuroimaging markup language that goes over TCP/IP. They can be on the same computer, or they can be on computers on other sides of the world. AFNI and SUMA don't have to be in the same place. It used to be, until a couple years ago, that you could only run one pair of AFNI and SUMA. So one AFNI could talk, if there was a SUMA on a system, it could only talk to one AFNI, and only one AFNI could talk to one SUMA. But we found ways to work around that, and so you can have many AFNIs and many SUMAs talking to each other if you need that. That's sometimes needed if you're running this on a server with other people running AFNI and SUMA. All right, what's a surface made out of? It's made out of nodes, and the nodes are connected by edges. Now here we see our surface. If we want to look, this is just our snapshot of our surface. This is our kind of a doppelganger of a surface. I'm going to close that. And I'm going to zoom in onto this, and I'll hit the letter P of the surface. So just do that. And if you look closely, you'll see that the surface has a bunch of holes in it. Our surface is now this holy surface. And so you'll see that it's with nodes that are connected to each other by edges. And that's what a surface is. It's just a list of nodes and edges. And that's what's in our files that describe the contents of the surface. And the coloring that we shade the surface, and we're just filling it in with something, either convexity or just some shading, or we may be coloring from AFNI too. So it brings up the topic of the geometry of the surface. So we know in any surface, one node is connected to another node and connected to another node, and they're all connected in a certain order. The order that they're connected to each other is called the topology. The location in space, we'll call that the geometry of it. Now, when these surfaces, these family of surfaces from FreeSurfer, they're all done with identical topology across their surfaces. So you asked about pale surfaces. We have the white, gray, inflated, spherical. You can have it flattened surfaces also. So these would all have the same topology, but they'll look different. How do we get to those surfaces? Let's do that. I'll zoom back out. And if you hit P again, you can go through the mesh, and this is the point mode. Then there's a hidden mode where you don't see it at all, and then back to the original, the filled mode. So P is a cycles among the different modes. All right. If you want to see the other surfaces, you can cycle among those with the comma and the period keys, which on the US keyboard are below the less than and greater than. It's a kind of an idea to go use those as arrow keys. So comma and period will take you among the different surface types. Okay, so here we have the pale surface. Here we have an inflated surface. We have a flat surface, flat patch. We have the spherical surface. We have the regular white matter surface. I'm using the comma and the period keys. I'm actually just doing the period key to go one direction. And then back to the smooth white matter surface. Yes?
Whole surface. Using Summa, you cannot modify anything, right? You have to come.
I'm saying, if you have a hole, yes?
Using Summa, you cannot modify anything of these parameters, right? You have to come back to FreeSurfer, let's say.
We don't have a way to fix surfaces in. We can show you where the surfaces are. We can even show you where there are problems, but we don't fix surfaces. You would have to go back to FreeSurfer. We do have a way to generate surfaces from scratch, though. So that can be useful if you have good segmentation. Yeah, we have a program called Surf Qual, which will report where the problems are. You can also look into the surface, particularly with the mesh mode. And in combination with AFNI. So I had seen in this data there were some oddities on the surface. So see if I can find. You'd probably find it before I can, but there's some places where the surface is a little strange. And you'll see that the surface is not exactly right for all the data. While they do a pretty good job, it's not perfect. And so for cases where you have lesions, some of these things aren't very good. And if you need to be precise, so some things are very strange where it's twisted up in there. So you can find some problems like that just by looking inside AFNI for the twistiness of the places like that. So we have a group. We work with a group that does epilepsy lesions. They won't use FreeSurfer for that because they need to see the surface pretty cleanly. Instead, they've devised a whole method of their own using isosurface inside Summa. And I'll show a little bit of that tomorrow.
So if you work in subject space, you can make your own surface for a subject also?
You can. So with mostly people will be using FreeSurfer, but if you have really good segmentation inside of your volume, you can potentially make it with AFNI. The Summa's isosurface program could be used to generate a surface.
But you have to have segmentation of FreeSurfer?
You need to have a segmentation, not necessarily from FreeSurfer. For the group that's doing the epilepsy studies, they have done their own with a machine learning algorithm that works very well. Yeah, so some of these surfaces, some of them are anatomical surfaces, right? Ones like this, the coordinates are real coordinates. This is the smooth white matter. This one's also a real coordinate. These inflated surfaces are not in their real, there's no real space for it. They're in roughly the right place, but the coordinates of their XYZ coordinates in here are not really defined well. The coordinates that they come from are defined well, so we can identify what anything is by looking at the same node across this family of surfaces and see the coordinate for that even in the inflated surfaces and even on the flat maps and in the spheres. Yes. So the way you look at one hemisphere is you click the left or right bracket. So if you hit the right bracket, that just makes the right hemisphere disappear, and you have just the left. And if you hit, you can bring that back by clicking it again, and vice versa. Alternatively, we loaded the both hemisphere spec file. If you have a spec file that only has one of the hemispheres, it will only show that one hemisphere. And generally, when we make this in FreeSurfer with the @SUMA make spec FS, we generate a both hemisphere spec file and a left hemisphere and a right hemisphere spec file.
If I would overlay two hemispheres just to compare, let's say, anatomical difference on the surface. Is it possible?
Overlay two hemispheres. They're kind of mirror images, right? So there is a procedure to do something like this, and it's complicated. But Hang Jun Jo had done kind of work where he looked at the the contralateral analog of for every node and the functional connectivity maximum on the contralateral side. And he looked for the differences between that on an autism study. And it's pretty cool. So correlation actually happens pretty symmetrically. So if you look at the contralateral side, it happens almost exactly in the same place as the same equivalent place as on the one side. So you always have this symmetric thing going on. So there are some ways to deal with it. You can also apply transformations. So you can apply transformations to surfaces. So we have a program for doing that. So you can take a surface and apply an affine transformation or a mirror image transformation and move it around as you want. So yeah, I have mirrored surfaces. So take one half. If you only have a left hemisphere, you can make a right hemisphere from that. Yes?
Let's say that you have the equation and the left hemisphere there's a lesion, and you want to fill the gap with information of the other hemisphere. Are we allowed to do something like this without making SUMA?
So someone else here was asking about stroke lesions and doing that. So you could potentially do this volumetrically and then generate surfaces from that and then look at one surface at the same time over the other one. It's a bit tricky and a little confusing, but you can do it. Yeah, so I think that's probably a little bit more advanced topic that we'll have to talk about. But yes, you can show pretty much as many surfaces as you want. And we'll show, tomorrow we'll look at hundreds of surfaces all at the same time. We keep all this information. One important thing, this is maybe one of the most important things about dealing with surfaces, is that that as opposed to volumes where we're looking at everything in a geometric position, the big advantage of working with surfaces is that things that are more spatially in common are going to be treated more equivalently. So this becomes important with things like smoothing. And this is one of the reasons that you do surface analysis with the surface directly and not the end result of the volumetric analysis. Because smoothing is a completely different operation. Smoothing will do things like here, if you're on two sides of a sulcus, smoothing in a volume will mix those together. But smoothing on a surface is a lot less likely to mix those together. You have to go all the way around, come back down to the other side to get the contribution from the other surface, from the other side of the sulcus. So dimensions that you work with in smoothing can be a lot larger, and it's a lot more robust to changes. That said, you still have to get the volume onto the surface in the first place, so you make decisions there of how you do that. A lot of people don't really think about that process. That is a process that does move things from the volume onto the surface, and then if you're going to move it back to the volume, you have to make choices there too. And there are lots of other issues. This goes on and on, just like I'm doing right now. So